By the early 1900s, steam was still the undisputed heavyweight on American farms. Most farmers who needed real pulling power relied on coal-fired steam traction engines. Complex machines with boilers, fireboxes, and a constant thirst for water. Running one meant managing pressure, feeding the fire, and keeping an eye on everything from the water gauge to the safety valve. It was a hands-on, high-risk job that took time, effort, and experience. So when the Hart Parr company rolled out a tractor that didn't require a boiler, water wagon, or steam license to operate, it caught everyone's attention. That tractor was the Hart Parr 3060, introduced in 1907. It wasn't their first machine, but it was the one that cemented their legacy. And at the center of it was an engine that looked more like a factory compressor than anything you'd expect to find on a farm. Charles W. Hart and Charles H. Parr were college friends with a shared obsession for internal combustion. They met while studying engineering at the University of Wisconsin and went on to form the Hart Parr Gasoline Engine Company. Together, they founded the Hart Parr Gasoline Engine Company and started building large stationary engines before moving into self-propelled designs. By the time the 3060 launched, they had already been refining their technology for a decade, and it showed. The engine was a horizontally opposed twin-cylinder giant that displaced 2,356 cubic inches. Each cylinder had a 10-inch bore and a 15-inch stroke, numbers that sound more like something out of a shipyard than a farm field. It ran at just 300 RPM, but produced 30 drawbar horsepower and 60 horsepower at the pulley. Most early gas tractors were lucky to hit half those numbers. This wasn't a machine that cared about speed. It was built for torque, and it delivered in spades. But power wasn't its only selling point. The engine used an oil cooling system instead of the more common water-based approach. Rather than circulating water around the cylinders, Hart Parr designed a closed-loop oil bath that absorbed heat without boiling off. Oil doesn't evaporate nearly as easily as water, and it doesn't freeze. Two huge advantages for farmers working in remote or cold weather regions. While oil can break down or burn off under extreme conditions, the rate of loss was much lower than water, and in theory, the system required less upkeep. That reputation for durability is where the nickname Old Reliable started. Hart Parr didn't just build engines, they branded them. Their advertising leaned hard on the idea that their machines could run longer, work harder, and require less babysitting than anything else on the market. And for many farmers, that seemed to hold true. But for all the marketing hype and genuine innovation, there's one question worth asking. Was the engine at the heart of the Hart Parr 3060 truly worthy of the name Old Reliable? If there was one thing that truly set the Hart Parr engine apart, it was its ability to run on kerosene, a fuel that most engines of the era struggled with. Gasoline was still relatively expensive in the early 1900s, while kerosene was far cheaper and more widely available on farms. So Hart Parr designed their engine to start on gasoline and, once warmed up, switch over to kerosene without missing a beat. That flexibility made it both practical and economical for large-scale field work. But making that work wasn't just a matter of swapping fuel lines. The engine itself had to be engineered for it. The 3060's two horizontally opposed cylinders were massive, 10 inches in diameter with a 15-inch stroke. Combined, they displaced 2,355 cubic inches, or 38.6 liters, and generated a steady 30 drawbar horsepower and 60 horsepower at the pulley. The massive volume helped vaporize kerosene more effectively inside the combustion chamber, which was critical because kerosene doesn't ignite or atomize as easily as gasoline. To further support kerosene operation, Hart Parr incorporated a water injection system mounted above the engine. When running on kerosene, water was dripped into the intake stream to prevent detonation, essentially keeping combustion temperatures under control and reducing the risk of knocking. It was a crude but clever solution, and it worked surprisingly well for the time. The engine also featured advanced design elements that helped it burn fuel more efficiently than many of its rivals. It used a single overhead camshaft, a rare feature for 1907, and hemispherical combustion chambers, which allowed for better airflow and a more complete burn of the fuel. These features helped compensate for the lower quality of available fuel and squeeze more usable power from every gallon. Starting the engine took effort, It wasn't just a matter of pulling a lever. Operators had to hand crank the massive flywheel using gasoline until the engine reached operating temperature. Only then could they switch over to kerosene. Get the timing wrong and you'd foul the spark plugs or flood the combustion chamber. But for those who got it right, the payoff was a full day's work on cheap fuel. And that was a big deal for turn-of-the-century farmers. The engine was oil-cooled rather than water-cooled, which was another edge in colder climates. Oil doesn't freeze and has a higher boiling point than water, which allowed the engine to run hotter, exactly what was needed for kerosene combustion. To cool the oil, Hart Parr used an induced draft radiator. Exhaust gases were routed through a tapered stack above the radiator, creating a vacuum that drew fresh air across the oil tank. It was simple, effective, and didn't require a water tank that could crack in winter. This wasn't just an engine that happened to run on kerosene. It was built for it from the ground up. From its oversized cylinders, to its unusual cooling system, to its forged steel crankshaft, everything was engineered to handle low-grade fuel while delivering reliable, heavy-duty performance. For all its quirks and complexity, the Hart Parr engine made kerosene work, and made it profitable. There's no question the Hart Parr engine was tough, but it didn't come with a user manual written for beginners. For all the praise it earned, this engine demanded a lot from its operators. It was reliable once you got it going and kept it maintained, but getting to that point took skill, practice, and a willingness to get dirty. The first challenge was just starting it. The Hart Parr 3060 didn't have an electric starter or even a compression release. To bring the engine to life, you had to crank the massive flywheel by hand. The flywheel alone weighed several hundred pounds, and if you didn't prime the engine correctly with gasoline, or if your timing was off by even a little, it simply wouldn't catch. And if it did backfire, you risked a broken wrist or worse. Once it was running on gasoline and had reached operating temperature, you had to manually switch the fuel system over to kerosene. If you made the switch too early, the engine would stumble and possibly stall. Too late, and you'd waste expensive gasoline. The sweet spot came with experience, not guesswork. Operators had to listen for subtle changes in the engine node and feel the temperature rise before flipping the fuel control valve. Even after you had the kerosene burning, the engine still needed close supervision. The water injection system had to be set just right to prevent knock. Drip too little water into the intake, and the engine could detonate violently. Too much, and you'd cool the combustion too far, leading to fouling or misfires. There were no automatic sensors or flow regulators, just a basic tank and a needle valve above the engine. A distracted operator could ruin a day's work with a few turns of the wrist. The cooling system also required special attention. The Hart Parr's oil-based cooling system didn't use water, which was a blessing in freezing climates, but it also lacked the built-in visual cues farmers were used to. Oil doesn't boil like water or blow off steam, so overheating wasn't obvious until something was already going wrong. The induced draft radiator worked by channeling exhaust gases through a stack above the cooler, which pulled air across the oil tank. But if sludge built up or airflow got restricted, the engine could quietly cook itself. You had to be proactive about maintenance, not reactive. Lubrication, too, was a hands-on job. The engine didn't have a pressurized oil system like modern designs. Instead, drip oilers and grease cups had to be checked and refilled regularly. The forged steel crankshaft was strong enough to last a lifetime, but only if you took care of it. Neglect the bearings or let grit into the crankcase, and even the toughest steel would wear down. So yes, the Hart Parr engine could run all day, in all kinds of weather on low-grade fuel, but only in the hands of someone who knew what they were doing. It wasn't forgiving. It wasn't simple. But if you respected it and learned its quirks, the payoff was an engine that could outlast nearly everything else on the farm. It's hard to separate truth from the marketing when it comes to a name like Old Reliable. On the surface, the Hart Parr 3060 engine lived up to it. It was dependable, powerful, and built with durability in mind. But as with most machines from the early days of internal combustion, reliability wasn't just a factory feature. It was a partnership between the engine and the person behind the controls. And not everyone had the patience or know-how to make it work. What gave the Hart Parr its reputation were the things it didn't do. It didn't overheat often, It didn't stall under load, and it didn't require the water babying that steam engines demanded. Thanks to its oil cooling system, the engine could run in winter without cracking its tank and run all day without blowing off steam. Its forged steel crankshaft, overhead camshaft, and nearly all steel construction meant that critical parts could take a beating and keep going. That mattered a lot in an era when replacement parts could take weeks to arrive by rail, if you could even get them at all. Operators who knew how to maintain the machine, how to time the fuel switch, monitor the water drip, and keep the flywheel spinning, often swore by it. There are documented cases of these engines running regularly into the 1940s, decades after they were built. That's not just a testament to engineering, it's a nod to the simplicity and toughness baked into the design. But that same simplicity also came with trade-offs, some of which we discussed earlier. While the engine had few moving parts compared to some of its later counterparts, the ones it did have were massive, exposed, and required regular adjustment. Lubrication was manual. Starting the engine was a chore, and a small mistake, like forgetting to open a petcock or neglecting to clean a plug, could mean an hour of wasted effort or a repair job in the field. And then there were the issues no one talked about in the brochures. The engine was heavy. Extremely heavy. The whole tractor weighed over 20,000 pounds, and a huge portion of that came from the engine block and flywheel. That weight made the machine hard to maneuver and downright dangerous on soft or hilly terrain. On more than one occasion, these machines reportedly broke through wooden bridges or became stuck in muddy fields where lighter competitors could pass. There's also the fact that while the engine was designed to run on kerosene, fuel quality varied wildly. Dirty or low-grade fuel could gum up the systems, foul spark plugs, or make combustion uneven, especially if the water injection system wasn't dialed in just right. It could run on almost anything, yes, but not always well. So, did it earn the nickname? In the hands of an experienced operator, yes, absolutely. It started when it was supposed to, pulled when it was needed, and didn't blow its top when temperatures dropped below freezing. But for the average farmer without training, the Hart Parr engine wasn't exactly jump on and go. It was more like an industrial commitment. The name Old Reliable might have been earned honestly, but only by those who knew how to treat it right. The Hart Parr 3060 engine left a deep impression on the farming world, but not just for how long it lasted. It also served as a cautionary tale in overengineering. For all its raw strength, this engine, and the machine it powered, pushed the boundaries of what was practical on the farm. With 2,355 cubic inches of displacement and pistons the size of coffee cans, the twin-cylinder behemoth delivered low-end torque like few machines of its time. It was designed to run slow and steady at 300 RPM, powering heavy equipment from its belt pulley or dragging wide implements across open fields. But that power came with massive physical size. The engine alone stretched over 6 feet long and made up a significant share of the tractor's massive 20,000-pound frame. In dry, flat terrain, that might not have mattered. But in soft ground or uneven terrain, the size of the engine created real problems. The machine could wear down axles and wheels prematurely, and transporting it across bridges or narrow farm lanes was an ordeal. Just relocating one of these tractors from a barn to a field could require planning that bordered on logistical warfare. Beyond physical limitations, the engine lacked adaptability. The 3060 came with just a single forward gear and one reverse. There was no clutch, no variable throttle for fine adjustments. If the job required finesse, tight maneuvering, pacing a smaller implement, or backing up repeatedly, it simply wasn't designed for it. You didn't drive a Hart Parr, you committed to it. Even though its forged steel crankshaft, overhead cam, and oil-cooled system were advanced for the time, they couldn't offset the core issue. The engine was too specialized. It was brilliant for belt work and hauling in open fields. But when American agriculture began shifting towards smaller farms with more diverse needs, the Hart Parr engine was out of step with the times. And then there was the economic angle. With a price tag and shipping costs that put it out of reach for many farmers, the 3060 was rarely a first choice for small operators. It was mostly adopted by larger farms or cooperatives that could afford to operate, maintain, and store such a large machine. That narrowed its appeal just as more versatile, easier-to-use models were entering the market. So while the engine was every bit the mechanical giant it was made out to be, its story is as much about scale as success. It worked beautifully, if you had the right kind of land, the right kind of operation, and the right kind of patience. But for an industry that was moving towards speed, agility, and affordability, even the most rugged design couldn't hold off change forever. By the time production of the Hart Parr 3060 ended in 1918, nearly 4,100 units had rolled out of Charles City, Iowa. That might not sound like much by today's standards, but at the time, it was enough to dominate the emerging tractor market. In its peak years, Hart Parr claimed over 70% of US tractor sales. The 3060 was a big part of that success, and yet in just a few short years, the market would pass it by. The world was changing. American farms were shifting from vast prairie fields to more diversified operations. Instead of just needing raw pulling power, farmers now wanted tractors that could do multiple jobs, handle tighter spaces, and be operated by a single person without much training. New models from companies like Fordson and Waterloo Boy, soon to be part of John Deere, were smaller, lighter, and cheaper, traits that made them better suited to a new generation of farms. Hart Parr wasn't blind to this shift, but they were slow to adapt. While the 3060 had earned respect for its durability and engineering, it was clear by 1915 that the industry was heading toward multi-speed transmissions, more refined controls, and compact designs. Hart Parr tried to modernize, introducing new models and tweaking existing ones. But the massive twin-cylinder engine that had made them famous didn't translate well into this new environment. And then came the merger years. In 1929, Hart Parr merged with several other companies to form the Oliver Farm Equipment Company. It was an effort to pool resources and compete with the growing industrial might of International Harvester, John Deere, and Ford. Hart Parr's name gradually disappeared from badges and brochures, though many of its engineering ideas lived on in later Oliver designs. Meanwhile, the legacy of the 3060 engine lingered, not just in old black and white photos, but in barns and fields across the Midwest. Many owners refused to scrap their 3060s even after newer machines came along. With proper maintenance, the engine could still be used for belt work well into the 1940s and beyond. A few even stayed in semi-regular service until the post-war years, grinding feed or pumping water on stubbornly self-reliant farms. Collectors today still marvel at the design. Restored 3060s command huge respect at shows, not just for their size, but for the unusual engine tech. Oil cooling, water injection, overhead camshafts, features ahead of their time, hidden in a 10-ton brute. Seeing one run in person is like watching a dinosaur walk again. It's loud, slow, smoky, and mesmerizing. But if the 3060 engine had one lasting contribution, it's this. It helped define what a gasoline-powered tractor could be. Not just an experiment or a novelty, but a serious alternative to steam. And while the engine may have eventually been outclassed, it wasn't forgotten. It proved that an international combustion engine, however big and demanding, could survive the brutal, muddy, never-ending work of American farming. And that alone made it more than just a machine. It made it a turning point.